All right, hello everybody. Welcome to the first content video in Python for Linguists. This one is about the first object type we're going to encounter in Python, and these objects are called strings. And they're the most natural way of representing language in Python, anyway, the most natural looking way. Um, for all of these videos, I'd like you, as you watch them, to have your hands free and to have a live shell open, a live interpreter. So whenever code blocks like this come up, please do sort of copy them, maybe modify them, use your own name instead of mine. Um, Most of them aren't going to be challenging in the sense of being exercises, but they get you used to just interacting with Python and just the sort of painful lessons of missing a comma somewhere, not closing parentheses, not having the right indentation. All of that sort of will become easier as you actually do the coding. So what is a string? I've defined three different variables here: name, greeting, and letter. And all of them have a thing in common. The value assigned to them starts with an opening quote mark and ends with a closing quote mark. And then if you ask Python to tell you the type, the object type of each of these, the values stored under each of these variables, type name, type greeting, type letter, you will get a class str, string, returned every time for each of these objects. So what's important to take away here is Python doesn't really care what's in a string. It's not a sequence of words for it. It's not a text. It's really, it can be just one character. It can be something that looks like a word, like my name, or something longer with more, complex internal structure. What Python really looks at when it sees a string is just an ordered sequence of individual characters. Um, and these characters can be alphabetical, right? Minimally just the letter A. That's just a one item sequence. Not very exciting. Can be something that looks like a word, like my name here. But there can also be numeric. We don't have numeric in here, but white space, punctuation characters, special characters. As soon as we talk about special characters in strings, things can get a bit difficult, so we'll save that for another time. But all of this stuff is just an element in a string. What's really important here is that white space looks just like any other character to Python. So when Python kind of interprets a string, there's no way it says my and name are two different words. Just sort of the y in my is in a certain position, and then in the next position, the next element comes, which just happens to be a white space. It's a point I belabor somewhat because this is a massive source of initial confusion. We're so used to reading text in a human way where we clearly see that this is words, there's a structure to it. This structure, if Python just has a string to work with, is in no way apparent to Python. So we need to kind of implement methods um, to teach Python or to convert the objects into structures where Python can sort of work with words or with whatever unit we require working with. So what can you do with strings? Strings are immutable, so I'll start with something you can't do. Once created, you can't change them. So there are other objects like lists, which we'll encounter next, that are mutable. We can kind of internally change things. With a string, you can't do that. You can take a string and then sort of modify its content and write that to a new variable. That's possible, but that's not the same as changing the object itself. Um, all of this kind of will become more relevant as we go on. What is immediately relevant maybe is things we can do like counting characters in a string. So if you take a word like linguistics, you can apply a function that's called len, short for length, to it. So you type that in your console, len linguistics, and you should get a number back that corresponds to what you get when you just use your fingers to count off the letters in linguistics. I need my fingers for that. Maybe you can do it without any manual help. What we see here with the len thing here, that's something we'll encounter quite a lot in Python. It's a function, and a function is in some ways similar to a variable. It's basically defined in some kind of way, has a name, just like a variable has a name. The name of this function is len. And then it doesn't have like a fixed value, but just a set of commands that it executes in relation to the thing that goes in parentheses, to its argument. So the way this is written in Python, somebody at some point wrote a definition for something called len, and that gives us the number of characters in our string, which is useful. We can also count the occurrences of individual characters, like the I's in Mississippi. And for that, we encounter a different way of drawing on inbuilt functionality in Python. That's a method. So the above is a function. This is a method where we have the object first, and then followed by a period, and then the method's name. And sometimes with an argument, sometimes there isn't even an argument. The difference here is that a function is defined on its own, and a method is always something that is immediately attached to a specific object type. So the count method here, that's inherently tied to the string object. Having these two ways of doing things is kind of a bit confusing initially, and while we're working with a limited set of things we can do, the best way is just to remember by heart, sort of when to use a len opening parentheses or a sort of dot do something, and the differences are going to become more apparent as you learn more about coding, but you don't need to worry about them at this point. We can do mathematical operations with strings. We can define a string like yo and add emphasis by simply using plus exclamation point. That appends an exclamation point to yo. So we now have if we do that, we have a three element sequence, yo exclamation point. And if we have yo and do times 3, we get yo, 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 a 6-letter sequence. Note that none of this changes my string, right? We have my string here defined. In the next line, we get my string plus exclamation point. That's really just saying, take the value of my string, interpret that basically. So give me what's in there, but add an exclamation point to that. And then Python displays that, but that's something it just displays. It doesn't store that under a new variable name, and the initial variable, my string, also isn't changed. And the same is true of my string times 3. This is just something that's evaluated. It doesn't create a new variable in Python. When we want to create variables, inevitably we need to work with this equals sign. Things that aren't possible are the division operator and the subtraction operator. So you can't divide a string by something, and you cannot subtract something from a string. Let's look at that in the shell maybe really quickly. Sorry, I've got some old code here. So if you're opening your shell, you first need to enter Python. I just happen to be in Python right now. So conceivably, you could do something like Mississippi minus PI, and then get I misspelled Mississippi. Mississippi. Except that doesn't work. We get unsupported operand type for minus. So we can't use a string and a string object and kind of have them related by this minus. And it's an operation that's simply not defined in Python. All right. One thing that we'll eventually, sooner rather than later, be wanting to work with is more than just individual words or sentences, but bigger sets of data. We'll find out how to kind of read all of this from file, which is the much more structured way of doing it, and the only way really that once you know a bit of programming that you're actually going to work. But for the purposes of practice, it's really important for us to be able to take larger chunks of language data and kind of paste them into Python. And there's a problem here. If you take multi-paragraph text, Python doesn't like to accept that. So here I define a variable called linguistics, and I just feed it the first 2 paragraphs of the Wikipedia entry for linguistics. You can't see that very well here, but you see the change in color right here. With the opening quote mark, it turns into green, so that means it's being read as a string, and that goes on all the way until the end of the line, but then it shifts to red, and red is indicative of a problem here. And in fact, in line 1 already, we get something called a syntax error, unterminated string literal. So basically this says a string literal, so you tried to define a string, but you didn't terminate it. So you didn't close the quote marks. And this is just what Python expects by default when defining strings, is that before we hit enter, we also close the string. Let's look at what this looks like in the live shell, just because it's more immediately visible here. So we now just use a quote mark, enter this sort of stuff, get invalid syntax. Where's the first problem? This is our syntax error here. Sometimes you need to look for where exactly the error is displayed, but we have here syntax error, unterminated string literal, and something to note is Python is relatively nice about helping us to pinpoint the error. So it tells us in line 1 is where the problem already is, and it actually points in a certain direction where we can already kind of make out where the problem is. So it's very important to start not going over these error messages and being like, oh shit, something went wrong, but to read them and to kind of make sense of them. Sooner rather than later, you'll be doing that, and you'll actually be able to just figure out what the problems are in code that you run up against. All right, let's switch back to the presentation here. The good news is there's a relatively simple solution to our string problem, multi-paragraph string problem. We just use 3 quote marks instead of just 1. That really kind of says to Python, okay, whatever I give you, just treat that as one string, and only when I close with 3 quotation marks, do something else. By the way, this also helps get around the issue of including quotation marks in the text you want to include, right? If you had that, otherwise you would break the string literal. Obviously, you can alternate between single and double quote marks, but sometimes maybe you want to quote a text that has both of these, and then also it's a really good idea to just use 3 quote marks. So let's see what the difference looks like when we do that. Let's go back to live coding, linguistics, and the only thing I'm doing different now is 3 quote marks. All right, close. Didn't complain. I now have a variable called linguistics, which I can call, and it looks like it's the whole thing. One thing you'll notice when I entered it, it had line breaks here. These get reinterpreted as special characters in Python. They're \n characters, so new line characters. When you print that though, they really come back out as line breaks again. Called it linguistics, I think. Right, so if I printed these new line characters that internally are represented just by \n, they actually get printed as new lines. All right, this is sort of the first bit about strings. Now it's time for you to do a bit of work on these. It's just a bunch of exercises to help you familiarize yourself with the object type. So find a multi-paragraph text that you can paste into Python and assign it to a variable. This can be a Wikipedia entry, song lyrics, your favorite recipe, whatever. And then just kind of count the frequency of individual letters, T, G, A, and Z. And you probably have expectations about which of these is more frequent, less frequent. If you really want to get into it, you can take a larger text and then look up the percentage distribution of individual characters in whichever language you're working in. You can find these on Wikipedia and then see how your text compares to that, if it's typical of the language, if there's something special. But just play around with this, and then try to calculate what the percentage of all characters in the text for each of these letters is. So let's stick to T, G, A, and Z. All of the stuff you need for this has been gone over in this lesson, but you may sort of have to put the pieces together. So pause the video here, do the exercises on your own. You don't also need to pause it because there's a link to the HTML slides as well, so you can just access these. And I'm going to finish here and welcome you all aboard the snake wagon. You'll get a wacky picture at the end of each presentation, just as an added incentive to follow along. Here's the image credits for the images I've used, and see you for the next video.